Check this.
Okay, welcome back. Today we're going to do the second day of parent functions and transformations. Last time we learned about three functions, linear functions, which are lines, parabolas, and absolute value functions. So we learned their shapes, how to move them up, down, left, right, and how to stretch them on a graph. Today we're going to add three more functions onto that and then we're done. Okay, if you didn't see part one, click the link above and you'll see part one and then come back and we'll do part two. Okay, so the three more functions that we're going to learn today. The first one is the square root function. We're going to add one more function to the list. Now we're up to 4. The square root function has a parent function that looks like this, y equals square root of x. And it looks like this. Now, you might be wondering, that's kind of an interesting shape. It doesn't look like anything I've seen before. But the truth is, if you think about it, isn't this just a parabola laying on its side, the top half? In other words, if you were to have another one underneath here, wouldn't this be a parabola? Like that's a parabola, right? Wouldn't it be a parabola just laying on its side? Well, a parabola laying on its side is not a function, so you can't have that. Okay, in other words, let's use the vertical line test. Draw a line straight down. You'll hit this twice. That's not a function. It fails the vertical line test. So this is a parabola laying on its side, but it's only the top half of the parabola. Okay, it's only one half of it, because if you had both halves, if you had the top and the bottom, you'd then have something that fails the vertical line test. Now, if you want the bottom half of this function, of this parabola, so to speak, this would just be y equals negative square root of x. So the top is y equals square root of x, and the bottom is y equals negative. And you put those two things together, they make a sideways parabola. But a sideways parabola as one, this is as two different functions. As one function, it would fail the vertical line test. It wouldn't be a function. So if you want to have an explicit function, if you're not in calculus, you want to have a y equals kind of function, which is all we're going to talk about in algebra, you need to have only the top of this, okay? Later on in your mathematical career, you'll learn about functions that go sideways, and that's fine. Okay, so I just told you it's a half parabola laying on a side, just the top half. And its parent equation is right there. Very simple. Y equals square root of x the way you know it. So how do you move this up, down, left, and right? Well, if you remember parabolas from yesterday or from the last lesson, y equals x squared was a parabola, and y equals, and then you put parentheses around the x and its horizontal shift, x minus h, okay, before you square it, and then plus k. Well, a square root function works exactly the same way, except instead of having a square, you have, I'm going to erase this now, you have a square root. But other than that, it's exactly the same logic, meaning your horizontal shift is inside, right there, that's your h, and it's going in the opposite direction that it looks like, that's why there's a minus there, and your vertical shift is right there, your outside number that's not inside the square root. So be neat about writing your square roots. Like for instance, if you write a square root function like this, y equals square root of x plus 3 minus 2. Okay, I did a good job with that because you can tell what's inside the square root and what's not. But what if I kind of was sloppy and made this too long, right? Or what if I did this? What if I did y equals square root of x plus 3? And what I really meant to do is y equals this. These are two different things. So you have to be very careful about where your square root symbol ends. If I want to have this be x plus 3 horizontal shift, I better make sure that this reaches all the way across. Don't leave it like this because this is something totally different. This means you're going up 3 spaces, and this means you're going left 3 spaces. So how you write this is very important. Okay, what's inside the square root and what's not inside the square root make a big difference. So be neat about how and be deliberate about what's inside and what's not inside, okay? Alrighty, so let's do a couple of examples just to see how this works. Oh, by the way, so we talked about horizontal and vertical shifts. What about reflections? Well, if you're reflecting vertically, you just stick a negative right after the equal sign. So equals and then put a minus right after that. That'll reflect it down here like I showed you a minute ago, and you'll have the reflection negatively. What if you wanted to flip this way, horizontally? Not downwards, but horizontally. We're going to talk about that at the end of the lesson, way at the bottom. We'll get to that later. And then of course dilation. If you put a number in A, like a 3 for instance, in front of your equation, that's going to change the stretch. It'll be like higher up like that, okay? And now how do you know how high to go? You have to make a table. And we'll talk a little bit about that too. All right, so let's get started. Let's get rolling with the square root functions. Now, what you want to do here, and what I'm going to do here, is to draw the parent function first for each one of these, just to make sure you can tell what's going on. So, you look at the function and you decide, hey, what shape is this? Well, I see a square root, so I think, hey, the parent here must be, identify the parent. The parent function here is y equals square root of x. And that looks like this. It looks like a half parabola laying on its side. So there's your dotted parent function right there. And the question is, what is this? This is the translated function. What's the difference between this and the parent function? Well, there seems to be a shift. Now, this plus 3 is outside of the radical symbol. This is called the radical symbol right here. And if it's outside, it's a vertical shift. It's a k. So this means go up 3. So all I have to do is draw this parent function 3 boxes higher than it already is, and I'm good. So here it is. Just take that, and we're doing sketches right now. We're not doing, you don't have to make a table and be exact. So just try to draw the same shape right there. And there you go. That's it. So we're sketching right now, so it's a little bit off. In reality, if you want it to be, really accurate, you would have to plot points from a table, but we're not doing that right now. Okay, how about this one here? Now, once again, the parent is still y equals square root of x. You recognize that this is not a parabola, this is not an absolute value, this is not a linear function, that this is a square root function. So right away you know the parent is y equals square root of x, and let me keep the same color scheme going. The parent is the red one here, right? So there's your parent, and you know your parent function is this right here. Okay, and now the question is, what is this doing to it? What's different here? Well, there's a plus 3, but this time the plus 3 is inside the square root. And that means it's a horizontal shift. It's an H. It's one of these. And you see in the formula, there's a minus in front of the horizontal shift, meaning the horizontal shift is always the opposite direction of what you think it is. This says plus 3 horizontally, so you're going to go to minus 3. Because in reality, the function really is y equals x minus h, and your h happens to be negative 3. And that double negative is why you see a plus here. Okay, but it's supposed to be x minus something. All right, so we're going to go to the left 3. That's what that is. This is 3 to the left. Left 3. So from the original starting point, which is the origin, the center here, we're going to go 1, 2, 3 to the left and draw our new starting point. Okay, and now you're going to draw this all the way to the edge of the graph. Don't be one of these people here that stops there. You want to go all the way to the edge of your graph and then put an arrow there. Okay, all right, how about this one over here? Well, this one's got 3 things going on. There's a vertical shift, up 4. There's a horizontal shift. It says x minus 2, but you know that's a positive 2. So this is right 2. And there's one more thing here. There's a negative right in front of right after the equal sign, right? So this means you're going to flip it upside down. This is a vertical reflection. So let's go ahead. Let's draw the parent function first. So we know the parent function is this right here. That's your starting function. And it starts at the origin, right? There's your starting point. And what are we going to do with that? Well, we're going to go up 4. So from here, up 1, 2, 3, 4. So now we're here, but I'm not going to draw anything yet. Then we're going to go to the right 2. So 1, 2, and that's my new starting point. So draw your starting point. And now, if there wasn't this negative here, you would just go ahead and just draw your thing. You'd be done. However, there's also a negative here. There's a flip. So you're not going to go up with your function. You're going to do the exact same thing, but reflected vertically. So you're going to do it this way. This last one actually has a number in front of the square root. And you can see that's a dilation. When you have a number in front of the square root, like here, so that 2 is stretching the function vertically. It's making it taller. So that means, okay, once again, here's your parent function, right? This 2, if you forget about the shifting here, its effect on the graph is that instead of it being this shape, it would be taller, twice as tall. And the only way to know how tall to go is to make a table. So we will be making a table for this one, but just want to point out what that does. All right, so let's go back to the original problem here. Okay, so what are all these? Each of these mean here? Well, this means down 2. This means left 4. Remember, horizontal shifts are always opposite direction on every function. And there's a dilation. There's a stretch of 2, which means make a table. If there's a stretch, you have to make a table. Let's just figure out where the center of this thing is. So from the origin, we're going to go down 2, which is here, to the left 1, 2, 3, 4. And that's my new starting point right there. Okay. Now, if this stretch wasn't here, just go ahead and sketch it. Good enough. But because there's a stretch here, I'll make a table. Now we already know where our starting number is. It's right here. See this? What x is that? That's x equals -1, -2, -3, -4. So we're starting at -4, and we're going to the right. We're going to be going this way. So that means our numbers will be going -4, -3, -2, that sort of thing. So -4, -3, Now, why am I using so many numbers here? There's a reason for that. When you do square roots, you get decimals. You get these things called irrational numbers. So one of the tricks that I use to cut down on the work is just do the square roots. That'll give you a whole number, and that should give you enough points most of the time. Let's avoid going into decimals if we can. So our first x is -4, and we already know what the y is because we already plotted that point. That's -4 comma -2. So we know this one already. But what if I plug in a -3 now? Plug in a -3 here. -3 plus 4 is +1. The square root of that, square root of 1 is still 1, and then 1 times 2 is 2, and then 2 minus 2 is 0. So the next point here is 0. So that means you're over here. Now -2 in here. -2 plus 4 is +2, and the square root of 2 is a decimal, so I'm going to skip that one. How about -1? -1 plus 4 is 3, and when you square root 3, you get a decimal, so I'm going to skip that one. You see what I'm talking about? That's why I have a lot of numbers here, but I'm not going to use all of them. All right, next one, 0. Well, if you put a 0 in here, 0 plus 4 is still 4, and the square root of 4 is a whole number. It's 2. And then that means this becomes the square root of 4, which is 2, and 2 times 2 is 4, and 4 minus 2 is back to 2. So this one right here, 0, comma 2. Put in 5, there's a whole number for you. So 5 plus 4 is 9, square root it, you get a 3. 3 times 2 is 6, and then 6 minus 2 is 4. And you see we have 4 good points, and we can use that to sketch your graph the best you can. You just try to make it look like a curve. Okay, so that was the square root function. That was our 4th shape. Let's go on to our 5th shape, and that's the cubic function, y equals x cubed, y equals x to the 3rd power. And it kind of looks like a parabola going up on one side, but going down on the other side. So if you think of a parabola being one of these, you can see the parabola goes up on both sides. But what if you took this leg right here, this side of the parabola, and bent it down so that it was down here instead? Okay, you just took this and bent it down. That would be a cubic function. Okay, that's the shape of a cubic function. And where is its center? Its center is the origin. So when we go up, down, left, and right, we'll be dragging this center point up, down, left, and right. And we'll be dragging the function from the center point like this, and we'll be moving it around like that. Okay, back to the center. Okay, so by the way, just to bring it back to parabolas. For parabolas, it was y equals x squared. And if you wanted to shift it, it was y equals x minus h squared plus k. Well, everything is identical here for cubic functions. Just change the 2 to a 3, and it's exactly the same thing. So let's go ahead and run through these relatively quickly, actually, because this one's really simple. This first one is x cubed minus 2. What's the parent function? The parent function is y equals x cubed. So that's your dotted parent function. I draw as a dotted line so you know that that's the parent function. And now what's our shifted function? What's our translated function? Well, a translated function has a minus 2 out here, not inside the parentheses, on the end, which means it's a vertical shift. So all you have to do is take this shape that you have right here and move down 2 boxes. Here's your center. Move down 2 boxes. Here's your new center. And then draw the same function. Half a parabola going up on this side, half a parabola coming down on this side, and that's your cubic function, just to the edges of your graph. How about this one here? Well, this one here has a vertical shift of up 1 and a horizontal shift in the parentheses of left 2. Once again, it says plus 2, so you treat it like a minus 2. The parent function, once again, was that dotted, okay, half parabola up, half parabola down shape. That's called a cubic function, a cubic shape. But we're going to take that from the center and move it which way? Up 1 box and to the left 2 boxes. So now my new center is here. And then from here, just pretend that's the origin and go half a parabola up, half a parabola down. Okay, finally for this last example here, we do not have a vertical shift. There is a 2 inside the parentheses, a plus 2, so this must mean left 2, just like it was over here actually. And there's a minus right after the equal sign, which is a vertical flip. Okay, so you start by drawing your parent function as a dotted line. And now we're going to do 2 things. We're going to go to the left 2, and we're going to flip upside down. So here's the center. We're going to go 2, 1, 2 to the left. So now my center is here. And instead of drawing it up to the right and down to the left, how do you flip this? Well, you flip it by going up to the left and down to the right. You do the opposite for each. And there you go. That's your flipped cubic function. Okay, that was our fifth function, the cubic function. And now we're going to go to the cube root function. Well, a cube root looks just like a square root. If you remember the square root from the first example in this section, it was exactly the same as this, except it only went from the origin to the right. It was half a parabola laying on its side. Well, a cube root has that happening on one side, but it also has a flipped one in the opposing quadrant, okay, going this way. But just think of it as half a parabola going this way and half a parabola that's flipped going this way. Take a look at this here. Okay, so what's going on with this one? This is the cube root with a negative in front of it. So what's the parent function? The parent function is y equals cube root, third root, of x. And we know that looks like half parabola to the left, sorry, to the right, and half parabola upside down to the left. It looks like that, right? There's the parent function. But the only difference here, there's no up, down, left, or right shifting to do, but you do have to flip it. So at the center, which is not moved, the center is still, 0, 0 at the origin here. You're just going to make the thing that's going up go down and the thing that's going down go up. So this upward trending curve goes down now. And this downward trending curve goes up. And that right there is your flipped cubic function. How about this one here? Well, this one here has a couple things happening. It's got a vertical shift up 2. It's got a horizontal shift. It says -4, so we treat it like a +4. This is right 4. The parent function is just like that. It's y equals the cube root of x. So the job here is to look at the function and identify what its parent is before you start doing anything else. The center is here. We're going to move the center up 2 spaces, so boom, boom, 1, 2 right there, and to the right 4 spaces, 1, 2, 3, 4, and that puts us right over here. So that means, and there's no flip, so that means from right here, I'm going to do, but going to the edge on the left requires me to go all the way to the edge of the graph. And there you go. So if you're in the academic class, you're done for today. If you're in the honors class, stick around. We're going to talk about horizontal reflections. Okay, now we're going to talk about horizontal reflections. Now we've been flipping things vertically simply by putting a negative after the equal sign. So let's say, for instance, you have y equals x squared, and you know that looks like this. How do you flip it upside down? Simple. You just put a negative right after the equal sign, and now it becomes an upside down parabola. So we see that just putting a negative after the equal sign will flip a shape vertically from its center wherever it is. So even if you have something like this, like y equals x squared plus 5, okay, if you just stick a negative in front of the x squared but leave the plus 5, this will be 1, 2, 3, 4, 5, and there's your parabola. This will be 1, 2, 3, 4, 5 up, but the parabola will be going in the opposite direction. Okay, it doesn't make the flip change, sorry, it doesn't make the shifting change, it just flips the parabola where it is. So the center was right here, it just flips it directly down from there. So we're going to do the same thing here with horizontal shifting, and we're going to be flipping horizontally from the same place that we are. So let's take a look here. We have a few examples here, and I think it'll be easier to talk about this if we go over to Desmo. And just for reference sake, here's the parent function, y equals x squared, right there. Okay, that's your starting function right there. If I put a negative in front of, or right in front of the x squared, or right after the equal sign, you can see what happens. It flips vertically. That's what we have learned to do. But what I want to do is I don't want to flip it vertically. I want to flip it so that the right side is on the left and the left side is on the right. Now here's the thing. A parabola is a symmetrical thing horizontally, meaning if I do flip it around that way, it's not going to look any different. Okay, so you're just going to have to take my word for it that it's been flipped. So how do you flip something horizontally? Well, you flip it horizontally by putting the negative in front of the x, not right after the equal sign. Now you might say, well, what's the difference? The x is next to the equal sign. But you saw already that putting the negative right in front of the x squared flips it downward, not horizontally. It does that, right? So how do I know that I'm supposed to put the negative in the parentheses and not in front of here? Because this would just create a vertical shift, sorry, a vertical flip, which is not what we want. We want a horizontal flip. So once again, you want to put the way you do this is that you put the x in parentheses and put the negative in front of the x, and that will create the flipped version of this. Okay, so I know that when you go to graph this now, we'll go back to the lesson plan here, this graph is going to look just like the parent function. So if your parent function is this right here, your flipped function is exactly the same thing, and you might see this on the homework. That's your flipped function. So it's exactly the same function. It's just that the left and right have been flipped, but you can't tell that by looking at it. All right, how about this one here? Okay, y equals, and you can see I've done the parentheses thing. The negative is inside the parentheses, not out here. So it's not a vertical flip, it's a horizontal flip because the negative is inside the parentheses. However, there's a complication. Let's go to Desmos and take a look at that. Now, if that negative wasn't there, okay, you'd have this function here, right? And this function here is you can tell it's a parabola, y equals x squared, but there's a horizontal shift of left 3. So if I click on that, you can see it's your regular parabola, but moved over 1, 2, 3 spaces. So that's, we know that. So I just got through telling you that if you want to flip this thing horizontally, like rotate this around and make the right be on the left and the left be on the right, that you put a negative in front of the x. But something weird is going to happen. Now watch this. Okay, it didn't only flip. It also moved to the right 6 spaces. Or you can look at it as, instead of moving to the left 3 spaces like it was supposed to, it moved to the right 3 spaces, which is wrong. Okay? And the reason why that's happening is just changing the x's sign doesn't, it does flip you horizontally. Absolutely. This is flipped. So if if this was the right, that's over here, and if this is the left, that's now on the right over here. However, it also changes your shifting. Okay, so here's the chalkboard again, and what we want to do is we want to graph this thing, okay? And we know how to graph it if there weren't a negative here. It would just be, like I said, a parabola moved 3 spaces to the left. But because there's a negative here, that means there's a horizontal flip, okay? And what we need to do when we have a horizontal flip, believe it or not, even though there's already parentheses here, we're going to put another set of parentheses around that, okay? And then we're going to undistribute in between these. So let me actually write this again so I have more room to work here. So we have y equals, okay, there's the original set of parentheses. Here's the x, negative x plus 3 that we have there. And here's the squared, okay? Just made a little bit more room here. And what you need to do here is, whenever you see a negative here, you need to go through this procedure, okay, bar none. Whenever there's a negative in front of your x, you have to do this. Put another set of parentheses around not only the negative x, but also if there's a horizontal shift like this, put it around that as well. Now, we need to do this. We need to make this x positive, okay? How do we do that? Well, to make a negative x positive, we need to divide it by -1. If you divide this by -1, it becomes positive x. But where does the -1 go? Well, we're going to put it out here as a -1 out here, like that, which makes this now positive. So, but we have to do the same thing to everything in the parentheses here. So same thing to the positive 3 here. If we're going to divide this by -1 and put its -1 out here, this becomes a -3. So I'm going to erase the positive and make it a negative. Now this process is called factoring. I'm factoring out a -1 from each of these. Now we're going to learn how to do factoring later in the year, but just for the purpose, basically it's undistributing the -1, okay? And just for the purpose of this problem, we're going to just flip the signs and put the -1 outside the parentheses here. So we have this situation now where we have y equals, there's no negative after the equal sign, so you're not flipping vertically, but there is a negative, and you don't really need the 1, just the negative is the important part. And now you have x minus 3, okay? 2 sets of parentheses and squared. This is how you should think of this. They're the same thing. They are the same thing. But this one tells you that you're moving 3 to the what direction? 3 to the right. Okay? That's 3 to the right. And that's telling you, because it's inside the parentheses, that it's a horizontal flip, which you can't see on a parabola, which you will see on the next couple of functions. So when we go back to Desmos now, you can see I have that here, okay? And here's the function we were trying to graph. This is the answer, okay? Take a little quick look at the answer there. And here's the function. If you factor it, you can see it's the same thing, okay? It does work. But in this version of the function where you factor out the -1, you can see that it's 3 to the right, not 3 to the left. Whereas if you only looked at it right now in this state, you'd think it was 3 to the left. It's actually the opposite, okay? A little tricky, but I'm sure you can handle it. Okay, let's go back to the chalkboard here. Let's take a look at this one here. This is y equals the square root of x with a negative inside, not outside. Okay, So what's the parent function? The parent function is y equals square root of x, and you know that it looks like half a parabola on its side. There's your parent function, right? And instead of putting a negative outside here, which would give you an upside down version of that, I'm putting the negative inside along with the x. So that's a horizontal flip. And like I said, for the horizontal flip, what you're supposed to do is put parentheses around the negative x and then factor out the negative so that you now have y equals -1, and then you have the x. And that right there shows you have a flip. But it's not really necessary when there's nothing but an x there. It kind of, you know, you can see it. So in this case, you don't really need to do that. But you should understand it still works even when it's simple like this. Okay, so what do we have? We have this shape flipped horizontally, and unlike the parabola where you couldn't see it, this time you will definitely see it. It's going to go like that. There's your horizontal flip on y equals square root of x. Let's go on to this last one here. Okay, we have y equals, we have what looks like a square root function that's moved up 3 and to the left, sorry, to the right 2, but then we notice, wait a minute, there's a horizontal shift here. You see that? So if that were not there, this would be like one of the previous problems, meaning if that were not there, you just go up 3 to the right 2, right? And here's your parent function. And you would just move it up 3, 1, 2, 3, to the right 2, 1, 2, and you'd start from there and just draw the same thing. That would be it if there was no negative right in front of the x. If there was a negative out here, well, you just flip it upside down, right? But that's not what's happening here. What's happening here is that there is a negative on the x. And if there's a negative on the x, you have to do this undistribute trick first. You have to factor out the negative. So here's what we're going to do. Y equals, going to make a little bit of room here. And there's my negative x minus 2, right? And here's my plus 3 still outside of the thing here. So I'm going to put parentheses around the negative x and its shift. And now what I need to do is pull out a -1, meaning divide both of these by -1. If I do that, this becomes a positive, and this also becomes a positive. And you can test yourself, check yourself. If you were to distribute this back, would you get this? -1 times positive x is negative x, yes. -1 times times positive 2 is negative 2, yes. And this is unaffected because it's not part of this whole process. And if you look at it, let me just write it. So now there's the negative, you have the x plus 2, and you have the plus 3 out here. So if you think about it, now you can see that this is up 3, which it always was, but this is not to the, to the right 2, it's to the left 2, because remember, horizontal shifts are always the opposite. And this is a horizontal flip. So that means, and we'll check our work on Desmos in a second, that means that we're going to do two things. We're going to shift first, and then we'll flip. So first we need to go up 3 and to the left 2. Let me zoom out a little bit. So we're going to take this parent function, move it up 1, 2, 3 spaces, and to the left 1, 2, and my new starting point is now here. And if this wasn't horizontally flipped, it would just look like that, right? But there is a horizontal flip here, so you go this way. Now let's go over to Desmos and see if Desmos agrees with me. So here's the function that we wanted to graph. We graphed it by hand without Desmos. Let's see if we got it right. Oh, by the way, let me do the parent function here. So the parent function is the square root of x. There it is. There's your dotted red parent function, like I do on the chalkboard. And here's the answer that I got. Let's take a look. Okay, and you can see that it starts at -2, 3, and it goes that direction, just like I did here. Exactly the same thing. So you can see we got it right here. And the idea is that when you see a negative inside, whether it's parentheses or the root symbol, okay, you know it's a horizontal flip, but it's inside something. If it's not inside, if it's out here, it's a vertical flip, like we learned before. Okay, we are done. I'll see you at the next video.